In this video, I'm going to cover the Year 9 Linear Graphing Fundamentals test preview. I'll put some time tags down below, so if you're following along with the test paper, you can skip to question numbers, and I'll also put some descriptions of what the questions are about so that you can skip to the sort of questions that you want some help with. We're going to start the test preview at question 4 because I can use this as a more broad introduction to linear graphing. Linear graphing becomes fairly easy if you understand that every linear function follows a rule which is y equals mx plus c. Now the m value that you can see there is the gradient. So this is the gradient, or how steep the line is. And the c value is called the constant. But more importantly, that also gives you the y-intercept. Okay, so I'm going to write that as the y-int from here on in, but the y-intercept. Now, what we can do is we can take each of the equations and you'll see, if you look at it, that what you've got is you've got an m value, the gradient, and you've got a c value, which is your y-intercept or your constant, if you like. Now, when we go to plot these, what we do is we have a quick look and we can see straight away with practice that the y-intercept is going to be at -6. Okay, and what that means is it's going to cross the x-axis, so the y-axis on the graph here at -6. Okay, but the reason behind that is important. So what we're saying is, if I make x 0, what will y be? Okay, and the reason that I'm making x 0 is that I don't want my point straying back and forward along this x-axis. I want it to be tightly held on the y somewhere. Okay, so in other words, my answer is going to be when x is 0, y is -6, so that I find where it intercepts or crosses that y-axis. So the way that I find it is that I am literally substituting in. So if I take my equation, y equals 3x -6, and I say I'm going to make x 0, like I've done just here, okay, so if x is 0, then y will be 3 times 0 -6. And so we know that y is -6. And now I know my y-intercept. So that means that if you've got to find the x-intercept, that's where it crosses the x-axis here. Okay, I can find that by just making y 0. So I write out my formula again. Y equals 3x -6. This time I say if y is nothing, what's x going to be? So nothing will be 3x -6. And now we're just back to balance method. I'll add 6 to both sides. I'll end up with 6 being equal to 3x's. Tells me to times 3, so I'm going to divide by 3 on both sides. So I found that x is 2. So now I know my x-intercept. Oh, not x, 2. Okay, so I found my x-intercept, I found my y-intercept. Let's plot them. When we plot them, if I plot my x-intercept first, I go always x before y, so I cross 2, y value of 0, and then if I plot my y-intercept, I've got that when x is 0, y is -6, and then you get yourself a ruler, and you draw yourself a line. Now, just while we're doing this, these lines go forever, okay, they're linear. And the other thing that we have to remember whenever we do a graph is we have to give it a scale. So we'll make those 10s, -10, -10. And you just make sure that you got x and y axes labeled as well. Some teachers like you to put the function equation on the line. So in a test, it's not a bad idea to do that either. And then you've got your full marks. Back to question 1 now, and we're just plotting points on a Cartesian plane. So let's have a go at plotting A. A is at minus 4, 9. You have to remember that all of these points follow a x, y coordinate. You always do the x before the y, or you always go across before you go up and down. Some people will remember a little limerick like you got to crawl before you can walk. Excuse me, whatever it is that helps you. So I'm going to go across to minus 4. You obviously don't draw this, and you go up to 9. I'm just trying to make this nice and clear on the video for you. Okay, and you're going to put one at minus 4, 9. Same deal. We might give our graph a scale before we go too far, so we'll call that 10, 10, minus 10, minus 10. And so this one here was point A. Next one, B is at 0, minus 6. So it's at 0, minus 6. Okay, didn't move along the x-axis at all. So we'll call that one B. C is at 1, minus 2. So we'll go across 1, down to minus 2. And that one becomes C. And last D, we go across 4 and up 6. So that one will land here. And that will be point D. Just as long as you remember to do x before y, you'll be fine. Similarly, if we have to do question 2 and we're trying to find these points, let's make that a little bit bigger for you. I'll start with point P. So if I have a look at it, it's sitting down here. What I've done is I've come across to 5 first, so that's minus 5, so it's got an x value of minus 5. Then we've travelled down to 8, so that's down to minus 8. And we've written in our coordinate x before y, same as when we're plotting them. C, we've come across here to minus 8, and we've gone up to positive 2, so it's got the coordinate minus 8, 2. And then K, this one's interesting. This one, see, we haven't travelled left or right, so we're still on the x-axis, so it has an x value of nothing, and we've come up to 6, so that's positive 6. And last of all, J, we've come all the way over to 10. We've got to put our units in again, haven't we? So we've got our x coordinate of 10, and then it's travelled down into the negatives down here to minus 7, so minus 7. And again, what we might do is we might just give this some values. And we're done. Question 3. Right, now, when we first unpacked this in question 4, you can see it just below in the screen. You can see that every single linear equation follows this set of rules, okay? So everything's got an m value, which is the gradient, and everything's got a c value, which is the constant. So when we have a look at these, this question is just asking you to identify them, question 3. So I can see that I've got an m value of minus 4, and I've got a c value of positive 3. And so we just write them in. So we've got an m value of minus 4. We don't put the x, okay, just the number, and a c value of 3. Always see people accidentally putting in the x. Don't do that, okay? Doesn't matter what order they're in. So you can see here they're trying to trick you. Your m value is minus 12. The negative goes with the number. And the c value is positive 7. The next one, we've got an m value of 5, so it's coming from here. And then we've got a c value of minus 7, which is this number here. Last one, we've got an m value of negative 5/7. It's fine to have a fraction, it's quite common. And this one looks like it doesn't have a c value, because there's no number by itself, no constant on the end. So that means that the c value is 0, okay? On a Cartesian plane, that just means that the line that you're drawing is just passing straight through 0, okay? So it does still have a y-intercept, it's just that the y-intercept is nothing. Now, if you're given a gradient and you're given a y-intercept and you're asked to write a formula, it's the same deal. Just remember, all of these follow the rule y equals mx plus c, and you can just write your answers out. in the same way. So if you've got a gradient of -5, you're going to have y equals something x something. So the gradient is -5 and it gets written in front of the x, and the y-intercept gets added on the end, which is -3. In the second one, the gradient is 6, so it's 6 in front of the x, and a y-intercept of -9, so the -9 goes on the end. The next one, it's got a gradient of nothing. We'll write this one twice. So it's got a gradient of no x's, okay, and it's got a y-intercept of -3. So this one would actually be better written as y equals -3. There's no need to put the gradient in at all. And similarly with the last one, if I've got a gradient of -7, it might read -7 x's and a y-intercept of nothing. The best way to write this one would be y equals -7x, with no need to put the 0 on the end at all. But just remember, especially when you see something in this format here, it does have a gradient. Its gradient is 0, and this one would be a straight line. So if we plotted this one on our Cartesian plane, it would just look like a straight line passing down through -3. All right, let's move on. Question 6. Find the equations of the lines given. This we need to talk about because what we haven't unpacked yet is gradient, and the gradient's got a formula. The gradient is the rise over the run. There is a formula. It's m equals y2 minus y1 over x2 minus x1. Might be worth pausing the video and writing that down. But what we'll do in this question is we'll just count for it. The other thing that we haven't talked about yet is positive and negative gradients. This line travels up, which is a positive gradient. But this line travels down, which indicates that it's got a negative gradient, a negative number in front of the x, okay? Think of them as being like your bank accounts. You want to see your bank account balance getting graphed like this going up. You definitely don't want to see it going down. So when we go to write this, what we do know is that both of these lines are going to follow the rule y equals mx plus c. And we need to just come through and fill out the gaps. And I like to do it backwards. So I like to say y equals something x, and I go looking for the c value first. I'm going to have a look at line A first, and I can see that line A goes through the y-axis here at +2. So that means it's going to have a +2 on the end for the c value. And to find the gradient, it's the rise over the run. So it's a rise of 1, 2 over a run of 1, 2. So that's 2 over 2, okay? And we can simplify that to 1, okay? So another way to write this, the final answer will be y equals 1x plus 2. And this is the answer to line A, okay? You might notice as well that the gradient, 2 on 2, is positive. That's because the line is going up like we talked about, okay? But also we've moved in a positive direction and then we've moved in a positive direction again. So a rise in the positive, a run in the positive. Let's have a look at the second one. In line B, I'm going to follow the same rule. So I'm looking at this y equals mx plus c, and I'm starting to write. I've got y equals something x, something, and I like to look for the c value first usually. Might use purple this time. Now I can set here traveling through 1, 2, 3, 4, 5, +5, so it would be something +5. And now I'm going to have a look for my gradient, a rise of 1, 2, 3, 4, 5 over 1, 2 in the negative direction. So it'll be a rise of 5 over a run of 2 in the negative direction. If you can't remember that, the other way to do this is just count the rise over the run, so 5 over 2, and then have a look at this line. And because it's travelling down, we know that's going to be negative. So we've answered the second equation. You can leave it in fraction form. You don't need to simplify it. Alrighty, midpoint. This is called the midpoint formula, and it's a bit of a weird looking formula, but what you're trying to do is you're trying to find an xy coordinate. And you're doing that by taking the average of the two x coordinates and the average of the two y coordinates. And I might be able to better explain that if I do a very quick rough drawing of this. If we had this on a Cartesian plane and we plotted that first point, that's this one here, 3, 1, it'd be about here. And then if we plotted 13, 7, it would be, over here somewhere. So you got your 2 points, and what you're trying to do in theory is you're trying to find the average between those two, or a point in between them. So what we need to do is, first of all, we need to give these a value. So it's easier sometimes if you just come through and you go, right, well, I'll call you my x1, y1 coordinate, okay? And I'll call you my x2, y2 coordinate. And it doesn't really matter which one you call which. I could have called the first one x2, y2. They'll both work in the formulas. Same with the distance one below. But you have to make sure you keep them as a pair. That's really the only rule. So let's see what we can do here. If I sub these in, I've got x1, which is 3. So it's coming from here, plus 13, divide by 2. And my y values, I'll just change colour to keep it nice and clear. That one might be, that's a fat texture. That one might be 1 plus 7, all divided by 2. And then we'll just solve it. So we've got an x coordinate of 3 plus 13 makes 16 divided by 2 is 8. And then we've got 1 plus 7 is 8 divided by 2 is 4. So my final answer is that the midpoint is at the coordinate position 8, 4. Let's move on and have a look at the distance. This is the distance formula, or for finding the length between 2 points on a Cartesian plane. And really, this is just Pythagoras. If I draw this again, just to try and help out a little bit, remember the first coordinate was at 1, 2, so it might be about here. And the next coordinate is at 7, 11, so let's say it's about here, okay? And it's asking for the distance between these 2 points. Now what it's doing is it's using Pythagoras basically to see how far you're travelling along the x-axis and then how far you're travelling up the y-axis, and drawing a triangle and solving for the hypotenuse. We don't need to worry about that though. All we need to do is just sub the values in. So again, what I do is I just pick a pair and call it x1, y1, and the other pair can be x2, y2. Same as above, it really doesn't matter which pair you call what, as long as you keep them together, okay? So x1 has to go with y1, in other words. Let's sub in and see how we go. So the distance for this one, or the length of the line, will be the square root of, and you'll be able to just type this straight into your calculator, x1, so 1, oh sorry, x2, so 7 minus 1, all squared, plus y2, which is 11, minus 2, all squared. And so what we'll have here is we'll have square root of 7 minus 1 is 6, and 6 squared is 36. And we got 11 minus 2, which is 9. 9 squared is 81. Which gives us the square root of 117, which if we put in our calculator, is a distance of 10.82.